Is the experimental method of determining the reaction rate. There are several methods are available for determining the rate of a reaction. First one is the determination of the volume of the standard solution required to titrate an aliquot removed from the system and cooled to arrest the reaction. For example, consider the hydrolysis of ester by using acid. First of all, you take the 50 ml of the ester in a conical flask, then kept in a separate room. Then after that 5 ml of the ester is removed from the system and keep it in a separate conical flask. Then arrest the reaction by using ice. Since we are using acid hydrolysis, there are some acid is present as a catalyst in the conical flask. Then titrate the solution by using standard base. From the titration value, we will get the amount of acid which is act as a catalyst. This is because at the initial stage there is no acid is produced due to ester hydrolysis. Then the same procedure was repeated for 20 minutes, 40 minutes, 60 minutes, like that. Okay. Then after this procedure, keep the solution for one full day, that is 24 hours. So most of the reaction is completed within this time period, and the same procedure was repeated. Thus we can find out the instantaneous rate. From the graph we can plot the graph time against concentration. From the graph we can find out the rate of a reaction. Okay, similarly we can measure the absorbance of a radiation at some wavelength at which given product or reactant absorb. Or we can measure the intensity of the emission spectrum of the system at a wavelength at which a given product or the reactant emit. Or we can measure the measurement of a variation of the pressure of a system with time, or measurement of a variation of the volume of the system with time, or determine the electrical conductance of a system. These are the different parameters which we can measure in a chemical reaction. We can determine the parameter depending upon the chemical reaction that we choose. Okay. The seventh point is the recording the mass spectrum of a system, or by recording the NMR or ESR or fluorescence or phosphorence spectrum of the system, or by measurement of the dielectric constant or index of refractive index, or by optical rotation, or by determining the mass loss if the gas is evolved. So this is the pattern of your observation. Okay, in this reaction the ethylene is react with ozone to give C2O4 oxygen and oxygen. So here we are measuring the concentration of the ozone at first at 0 time, that is initially the concentration was 3.20 into 10 to the power 5, and after 10 minutes we will get the concentration as 2.42 into 10 to the power minus 5. Similarly we can measure the concentration for 60 minutes. So the reaction is almost complete within this time. So we can measure the rate of a reaction by the average reaction method.